back. It's me. So, I haven't been streaming in, here it says 6 days. Fuck me. So, now I'm hoping to wrap up the functionality in our build your own Lisp program. And hopefully I'll do a bit of research on what to learn and do next. And I realized that I lately have been a lot more focused on explaining the things, in the sense that I'm behaving like a teacher of some sort, which wasn't my initial idea when starting this channel. So I won't film as if I know a lot more than you do. I'll film and present myself as if I'm learning these things and not if I'm teaching someone these things. I think that's the difference, and those are the changes that I want to implement here. So without further ado, where are you? Where are you? Where are you? What's this? Compiler from scratch. Ooh, this seems interesting. Let me just subscribe to I'm already subscribed. And also, now Andrea seems like an old school programmer. I'm also gonna subscribe to her as well. And I'm gonna watch later. Maybe even yeah, a bit later. Okay. Because we are here. We are here. And I did a mistake. Functions.c. Okay. Let me just create the ambience here, in my working room. I want to turn off the light to have a more hackerish feeling while I'm doing this. Just a second. Alrighty, now I look dangerous. So, let's continue. I also have in the bottom right, if you can see, I have my tablet. Maybe I'll just increase it in size a little bit so you can see. I'm mostly gonna write stuff related to whatever I'm learning. By the way, I hope you like my new wallpaper slash screensaver slash. Look at this. It looks really nice. For some reason, these two floppy. By the way, for those of you who don't know what this is, these are floppy disks. These two are looking at each other for some reason. I have no idea why. Doesn't matter. So let's do this. So again, what we did there is that we implemented lambdas, which are a simple and powerful way of defining functions. And they're gonna increase the expression level of us as developers, but there's a slight problem. The syntax seems, you know, a bit overboard, a bit clumsy. There are too many symbols involved and a lot of different things running around. So what we should do is we can try to write a function that defines a function itself using some simpler syntax. What? So what we want is a function that performs two steps at once. First, it should create a new function, and then it should define it to some name. And the user will supply the name and the formal argument. So I would need this. Create a function that defines a function itself. Defines a function itself. So the user will supply the name and the arguments. Okay. So there's an example of a function that does this. It takes as input some arguments and some body. It takes the head of the arguments to be the function name and the rest to be formal arguments. Okay, let me think about this for a second, for a moment. So what it does here, we have a function that is doing this. It will take as input some arguments and some body. It takes the head. What does it mean, the head of the arguments? What does this even mean, the head of the arguments? Okay, let's try this. Maybe I'll understand it better once I. So I have the. Give me the orange one. I have this. I'm opening this. How is this working? No idea. Then I'm defining head arguments. Then I'm having tail arguments, and I should move all of this a bit here so I can have more space. Body. What is this doing, man? I have no idea. So this is a function. It takes as input some arguments and some body. So these two guys. Ah, wait. Okay, let's try to understand this. It takes it looks so ugly. What? It's Dracula. How can I set it to be default? Okay. Why? And why is this working like this? So we have arguments and body as inputs here. it takes the head of the arguments to be the function name. It's here. Def head arguments. Ah, okay, head is a built-in that we have, which I've completely forgot. So this is a built-in. And the rest are formal arguments. These are the formals. And this is the body. Wow. Is this working? Functions, is this working? I think it is. So if I do this, and if I do this, and if I do so how the fuck are you doing? Are you working? You. So what we actually did here is we defined a function over a function. So what am I doing here? I'm entering the loop and evaluating. I'm reading and evaluating the input here, right? A new environment, implementing built-ins. And here it starts. What? Do I have two of these? I do have, no, this is read none. I thought I duplicated a function definition by mistake, of course. So let me try to debug it dry without the debugger. So we are hitting the elbow read, which is this one. and we are using the abstract search tree, which is basically gonna tokenize our inputs. And we have all of these different delimiters or symbols, and based on them we are creating actually different. Let me try to debug this guy. Is it GTB functions break 527 run? Okay, yeah, we are here. So what do I have here? Print t tag. This is, so what this is the root node of the abstract search tree. So this is the root node. Can I skip just a second? Let me see. Let me ask the daddy. What are the most important command? Is it git key? Can you see it? So let me just remove this for now. Is it key? For debugging C applications. So this is how we start a program. This is how we run the program using the keyword run. This is how we set breakpoints and watch points. Set a variable to stop when a variable changes. Okay. This lists all breakpoints. This temporarily enables and disables breakpoints. Inspecting program state. This is how we print variables. Continuously print the value of an expression after each step. Oh, this is interesting. I didn't know about this. Backtrace. Now this is out of a step into the function. Continue until the current function returns. Is it finish? Wait, let me check. So what I want to do is to trigger the next instance of this. So if I do finish, yeah, finish, this is what I want. So now if I print t tag, it's an expression, symbol, or regex. But now if I print t abstract search tree, what does it consist of? I think I have it written somewhere. Just a second. I have it written somewhere in my tablet, but where? I want to see the contents of this. Okay, let me just increase the size of this. Yeah, I know you can't see anything, but this won't be visible all the time. It's only gonna be visible. So macros. where the heck? Yeah, it should be here. Here somewhere. I think I wrote the structure. Oops. I wrote the structure of the abstract search tree, but convert abstract search tree to the S expression. Evaluate the S expression here. Okay, this is how it parses text. But where the heck are you? Not here. Not here. Let's ask ChatGPT, what properties does have? Mat compile, yeah, this is the library. This structure represents the abstract syntax tree. The abstract syntax. Oh, yeah. This is the one. This is the one. This is the one. So if I print contents, it's a def. So if this is our let me just hide this. Yeah. So if this is our structure, the first token is def. So let me just try this. Okay, body. I just wrote this so I can tokenize it for myself. Okay. So the first one is def. This is one token. So if I do now, finish. Five, 6, 9. Why did it? Why did it stop here instead of hitting 5 to 7 where I put the breakpoint? It stopped here for some reason. So why? It's def. Does def have any children? Print t children num. It has 5. Def has 5 children. print t children 0 contents. It's an empty space. The first one is another def. The second one is an empty space. The third one is an empty space. The fourth one is an empty space. Where the hell do I get these? It's here. No, it's a different. Wait, if I skip. No, not skip. Finish 527. Print the content. Print the its contents. So it's an empty space here. What am I doing here? Undo, everything undo. Print the children none. It has 3 children. It's this. Was the first one? It's the fun. And the second is the closing one. It's an expression or a Q expression. Okay. So let's stop this. Stop. Okay, let's look at elval evil. Where is it? It's here. So what do you take? You take a Lisp environment and a Lisp value, and I'm comparing if the type is a symbol. If it is, I'm getting it from the environment. If the type is an S expression, I'm getting it from here. Interesting. Okay, let's talk about something else. Let's talk about carrying. Where's my pen? Here. So it's here. So what do we have? Currently, functions like the plus take a variable number of arguments. Take a variable number of arguments. In some situations, that's great, but what if we had a list of arguments we wish to pass to it. In this situation, it's rendered somewhat useless. We can try to create a function to solve this problem. If we can create a list in the format we wish to use our expression, we can use eval to treat it as such. In situations of plus, we could append this function to the front of the list and then perform the evaluation. So the concept is called currying. What is currying in the domain of programming? What does currying mean in the domain of programming? Currying is a technique used in functional programming that transforms a function with multiple arguments into a sequence of functions, each taking a single argument. Instead of calling a function with all its parameters at once, you can call it step by step, with each step returning a new function that takes the next argument. So conceptually, we have a function which takes ABC as inputs, and with currying we get this, a function that takes B, a function that takes C, and then the result. Instead of providing all three arguments at once, each function takes one argument and returns another function until all arguments are provided. But well, yeah, this was my next question. Why would we use this? Why would we use currying? Partial application. Currying allows you to create specialized functions by fixing some arguments in advance. Higher order functions, it fits well in functional programming paradigms where functions are treated as values and code reusability and composition. It enables you to build reusable functions improving modularity. So what is currying? Again, it transforms a function that takes multiple arguments into a sequence of functions that each take a single argument. Into a sequence of functions that each take a single argument. Into a sequence of functions taking one argument. Okie dokie. Okay, let's now talk about something else. But let me just check this again because I want to understand this properly. Okay. Let me just ask something. Ah, I forgot to ask him. Yeah, what you're working on here looks like a Lisp-inspired function definition, a custom Lisp-like language. Let's break it down and walk through what this expression is doing, how it works. Here is my mind. So what I defined is a higher order function, likely aiming to create anonymous functions, lambdas, in a recursive Lisp-like syntax. Here is what each part means in context. So def is declaring a function. Fun is defining a new function by decomposing its arguments into its head and tail parts using recursion. So it looks like a function constructor that takes a list of arguments, args, and a body uses head to extract the first argument and recursively defines the rest of the function with tail. And this line defines a function called add together that takes two arguments, x and epsilon, and returns their sum. This is similar to defining a function in traditional Lisp or scheme like this, or more lambda-like like this. And what's happening under the hood? The fun macro creates new functions by extracting the head using head, recursively building the body using tail, wrapping the whole thing in a lambda function, which is this in my syntax, allowing for lazy or delayed evaluation of body. Thus, fun becomes a syntax sugar to easily define functions with a clean pattern. Okay. Tail. Built-in tail. This is the guy. So I'm having all of these assertions. Then I'm taking the first element of the Lisp value, and I'm deleting. Then I'm deleting it, and I'm returning v. Wait. Let me imagine the model of this again. I think now, before I decide to venture out further, I really need to do a deep down debugging session on this. So let's do this. Let's start. Okay. So where should I break it? I will read. It's here. If the tag is a number, you return L will read number. If the tag is a symbol, you return okay. So what this does, it creates a number using the Lisp value constructor, and all of these are doing the same actually. And every time I have return X here. Break 5, 7, 1. Run. No. This. It's 5. So the first one that we created is 0, 1, 2, 3, 4, 5. It's a Q expression. 5, 7, 2. Actually, I have them somewhere written in my tablet, so I don't need to switch every time I want to. Let me just find it. Let me just find it if I can. I should find it. Seems like I'm a victim of too much information here. Where the heck are doesn't matter. I'm gonna write this myself one more time. So it's 55, right? Yeah, 46. So it's error. It's a number. It's a symbol. It's a function next. It's expression, co-expression. And then it's an S expression. So how can I make this more visible? Sorry. I'm here. I need to make this more visible, more tangible to the naked eye. No, this is ugly. No, I don't like this either. Just testing the pen. Okay. I think I'll get around. So it's the type 5. So it's an S expression. X so what do I want to find out about this? So it's 5. It's cell. How many cells do we print X count? How many elements do you have here? Only one. So what do we find in the first element? Type. It's a symbol. It's this. So how did this go? I think it went here. It triggered the function. Then it went all the way to here. It looked at the tag. It most probably was the S expression. Then it tried iterating through the children of the abstract syntax tree. Bum 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 bum. It continued here, and then wait, what's going on here? So I have a for loop triggers all the children of the abstract syntax tree. Bum bum bum. Why is it doing this again? Oh, I'm so tired today. I have no idea what's happening here. So wait. Children on I. So I'm going through this. If I hit one of these, I continue. Okay, what do I do next? Finish. 5, 6, 9. It's a Q expression. Print X cell. No, X count. No, it's count X cell. 0 type. The type is so it's def. Why is def triggering only after? There's a really weird way of how C does all of this routing and the navigating between different branches of execution. I still have no idea how this works. Wait. Wait. breakpoints and watch points. Maybe I should use a watch point here. Maybe a watch point is more useful here. Set a breakpoint in another file. Set a watch point to stop when a variable changes. Show local variables of the current function. Okay, so let me even do this. Let's create an even simpler method like this. The most simplest one there is. Use this for testing and examples. Okay. T tag, print T. So this is the root. Is it count? No, there's no member named count. What are the member names of the abstract syntax tree? Where the fuck are you? It's 5. So we have 5 children here in this element. In this method. It's the simplest one I could create right now. So we have 5 of these guys running around. Of these running around. So let's look at them one by one. T, the first child. Contents. It's an empty string. The first child has nothing. The second has a def. This one has nothing. The third one has nothing. And the fourth one has nothing. Why? Because the first one has, I think, children of its own. No. The children. 0 tag. It's a regex. Contents. It's nothing. So the first one has no children of its own. Is this the empty space here? Are we talking about the empty space? How much children does the second guy have? So the second one has no children of its own, but it's a def. By def, I think, oops, it's an expression, symbol, or a reg. It's basically an expression because I'm defining a method here. 1, 2. What about 2? It's empty, but how many children do you have? Children, none. It's 3. Children, 0. Sorry, children, 0. Contents. It's an open brace. Then we have add. Okay, now we're gonna have the closing brace, right? Yeah. Let me just write this. So where's my pen? Here. 0 is empty. Number 1 is def. Number 2 is the add. The whole add structure. What I'm assuming now will happen is that number 3 will have no children. Children, none. It has 5. 0, 1, 2, no, 0, 1, 2, 3. Ah, yeah. So children, 0, contents. What will this be? What do you think? I think it's gonna be the open brace. Yeah. The first one is the lambda sign. The second one is an empty space because all of this is an empty space. The third one will be this, and the fourth one will be the closing brace. So actually the fourth child is empty, I think. Children, none. Because the first and the last children in this abstract syntax tree are denoting what I'm assuming are the start and the end of this token. Again, I'm just assuming this. So let's, where am I right now? I'm here. So if I do next, I'm here. 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 It's triggering an LLS expression. So what's gonna happen next? I don't care about this. Next. Next. Teach children. But none of are none of his children. Yeah. Now it continues. So it won't trigger this line of code until what happens? Until no of his children are an opening brace, closing brace, or a regex. Why am I doing this? Why am I doing this if I can ask my good friend ChatGPT for some much needed explanation? But why can't I copy this? Can I open it in visual? I can't open it in visual, but can I scroll down? Why can't I scroll down? Wait. How to copy a snippet code in Vim to use in external files? There are a lot of different methods. I like the first one. It's hacky in a sense. So enter visual mode. Oop, nice. Then I do this. I copied it. No idea. Let's test it. No, I didn't. I didn't. Why I didn't copy this? I did something wrong. So again, enter visual, do this, like this. How do I copy it then? So it's plus epsilon. Then doesn't work. Doesn't work. Why? Plus, no, it's not plus. It's like this. Plus epsilon. It won't work again because I did a mistake here. Wait. So it's here plus yank. I mistyped. Why? It's not in my clipboard. It's not in the clipboard. It's not in the external clipboard. I don't seem to be able to paste the contents using Control V That is, nothing is stored in clipboard. Okay, so let's test this. Let's test this. So it's minus. Okay, so my clipboard is not working. Why? Is there any other options instead of... Set mouse A. Why? Why are you not working, man? What's wrong with this? Okay, is now Vim better than Vim? I mean, what even can it have as a functionality? Configuration. Okay, let's install now Vim. Let's install now Vim. Do I need to run everything again? Like this. Now Vim, why doesn't it trigger? Vim. Now how do I run now Vim? So I'm installing it. Ah, it's nvim. Why? Oh shit, what have I done? Why do you even... Why would you call it sudo package install neovim if you're gonna later call it nvim? Let's see this. Nvim functions.c. Ooh, it is better. It is better. I already like it. I already like it. It has this selection, which is nice. No, this is the one that I wanted. So, visual. Better work, you fuck. Oh, it works. Okay. Hopefully I copy this. No, I didn't. how to copy content using NeoVim. So again, if it doesn't work, what the fuck? It is faster. It's a lot faster than Vim. So v all of this, copy. So it does this plus epsilon. It's yanked. Please, fuck me. Can you explain me how this would work? With the following input. So what else I wanted to do? I wanted to check so this as well, plus epsilon. Some extra code. Okay. And no. No. Visual again. Yank is my favorite command from now on. So let's walk through LWL read using your input. The goal is to see how this code builds the abstract syntax tree and how LWL read converts it into an internal Lisp value. I'll explain step by step what happens. Okay. So we have input and tokenization. The parser splits the input string based on the grammar defined by MPCA language. This string matches different grammar rules like symbol, sex expression, Q expression, and so on. So this is how it looks. I have the root, which is true. Then I'm having the expression. I'm having the symbol. I'm having the Q expression, which is a symbol, an S expression, all of these. So what happens? The first step. So the first tag is the root node. Yeah, it matches this case. And the new S expression is created. Now the children. I create a symbol. This returns an LL containing the symbol def. Add this to an S expression. Second child. So I have an S expression, I have a symbol, a Q expression which has this symbol, an S expression which has this symbol, and a Q expression which has these symbols. Okay, I think I understood this. I think I just have a pretty uneventful and slow night, so wait, let me do this. Understand how the flow works. Okay, I just wrote this. Hopefully I won't forget it. I shouldn't. I definitely shouldn't.